So once again, on this first part, part A was just a function of drawing the torques, doing the sum of the torques. Okay. So the sum of the torques on this, yeah, I am recording. So the sum of the torques on this is what gives you the torque that's pulling this bar down is that negative mgx sine theta equals I alpha, which in this case becomes dt theta over dt squared. Okay, so this is the answer to this part I. In the second part, I, we're doing some mystical mumbo jumbo. We have to do sine theta is approximately equal to theta. That's the first part. And then we have to get the d2 theta over dt squared by itself. So by doing that, dt, oops, just kidding, d2 theta is equal to negative mgx theta over I. Okay, this we're sort of trying to be slick and saying this realization is actually very deep, but this mgx theta over I is similar to the concept of g over L when you plug everything in. Right? So the way this is similar is that remember we plugged everything in. When we did mgx over 1/3 m, let's say this is L for the full length. mgl over 1/3 ml squared, right? By doing this, the m's cancel, this L cancels, and we basically get 3g over L. So this is the ratio of gravity to length. That is what determines, like, how do you make this jump? I honestly don't know how you would do that by yourself. Maybe just you're like, what the, I have no idea what to do. And then you just plug in the only thing that you know, which is the moment of inertia of that bar. And by doing that, you get this 3g over L. And then the light bulb turns on and you say, wait a minute, the ratio of gravity to length is connected to a pendulum. And then you have to just pull out of your memory that omega is the square root of g over L. So that means omega squared is equal to g over L, right? So what's going to happen is from that, I'm able to say omega is equal to the square root of mgx over I. Where'd my theta go? Oh, yeah, okay, it's still there, it's fine. Okay, so our theta is still there. We're just plugging in and saying this is omega squared. Right, so then from this, we can say, it's because we've identified what omega is. That's the important part. This is just, like, if we come up with this statement that says d2 theta over dt squared plus mgx theta over I equals 0. That's the differential equation that describes the motion of this object. From that differential equation, we identify the relationship between gravity and the length. And from that, we can say, okay, omega is equal to this. And then we use the standard definition, finally, an easy part to the problem. The definition of omega, which is 2 pi over t. So then, t is just 2 pi times the square root of I over mgx. Theta is still over here. We're not using this equation to get t. We're using our a part of it. So this statement could be put like, I don't know, you can sort of say like, this is like omega squared. So it's like d2, like the acceleration is equal to the negative omega squared theta. Now, that seems very confusing, I know, but do you remember when we talked about oscillators? And like, if you have something that oscillates like this, right? Like it starts high, goes down, comes back up. What do you use to describe this? Cosine theta, right? Now, let's talk about that. This height right here is A. So what do you use to describe that position x? does it make sense that x is going to be a times cosine theta? Does that make sense to you? Right, it's going to be the number cosine theta comes out to be times a. That will give you this height right there.
So the height will be given by what? Elliot.
It's worth it. Because basically this is going over all of harmonic oscillators again.
Oh, no water.
Okay, I'll tell you what. Like, look at the harmonic oscillating stuff tonight, and then I can talk about it again tomorrow if you want. Yeah.
So in the end, you end up with a 3G over L. How did that convert from G over L?
No, it's G over L is the relationship that determines omega.
But after you did a ratio of mg over
Yeah. So what I'm saying is the concept like of G over L is omega squared, or is omega, G over L is omega, sorry, the square root of G over L is omega in general. Okay. For this particular oscillator, omega is the square root of 3G over L. But I don't have to have 3G over L in there. I can leave mgx over I. You get what I'm saying?
Yeah.
So actually, okay, the question is good. This also would work. Let's say for example, you did this. You said mgx over I. Okay, that's going to come out to be 3G over L. And then you said, based on this relationship, I think that's going to be omega squared. And so you said omega is the square root of 3G over L. And then you said that is equal to 2 pi over t. So you said t is equal to 2 pi times the square root of L over 3G. That is also a correct answer. Right? Because you just converted this into something else. That's all. I mean, you've used it kind of, well, yeah, correct enough. So, now, let's take a look at something, which is what I really wanted to talk about. This is for, I think this first part is a no-brainer. That's easy. If you know what those terms mean, this is easy. This part II is ass-numbingly difficult, but look, and that's 4 points. But look at this, the rest of it. It's easy. It's just it's like right out of an experiment. Right? How would you measure this? Describe the experimental procedure used to make the additional measurements needed to determine and include how you would measure I. So all you do is figure out a way, let this swing back and forth and time it. And then use that period, because if you know the equation for the period, you can plug that in and get I. You know what I'm saying? So most of the points in this problem are given to you because this is insanely difficult. So if you have your head on straight and you don't freak out, you can get a lot of points on various problems by just staying calm and doing what you can. That was the whole point.